Hello everybody. In this video I will be introducing databases. Whenever you have large bodies of data to store, process or reference, you will find a database. All databases, regardless of scale, have a few basic features in common. They are repositories of data which we can use to generate information. Computerized databases, many of them available online, have had a tremendous impact on our society. This is one of the reasons that the time we are living in is often called the information age. We have faster and easier access to information than at any previous time in the history of humanity. In fact, a huge problem these days is information overload. Too much information for us to process and integrate. A lot of this is collected in social media sites and indexed by search engines. To manage this flood of data, these sites use databases, often extremely large databases, to manage the volumes of information that they collect and make available. We all use databases. Almost every interaction with technology these days involves some level of database use. Whether it's using social media, looking something up on the internet, shopping online, or making a phone call, all our interactions involve databases. And often several different databases for different parts of each interaction. Your device, internet services, and online store or social network all have databases that are involved in the transaction. A database is the foundation of any dynamic website, including any of the social networking applications or search engines that you've used. But databases don't have to be big. Any small collection of data, such as the contact list on your phone, is also at heart a database application. Databases even existed before the invention of computers. The Yellow Pages is a database of phone numbers in book form. A library catalogue stores book details on index cards, and a library itself can be viewed as a database of books. A database can be any structured set of data. Computers are devices designed to process data. This makes databases and computers a perfect match. Computerized databases become powerful tools for organizing data. Software does the searching for you, so the data is easily and quickly accessible. Highly sophisticated results can be generated from extremely large datasets relatively easily. As a result, you will find databases everywhere. The databases can be extremely small and limited, such as the small dedicated databases used by your phone to store phone message and call records, or the email archive on your computer. They can also be extremely large, such as the population register for an entire country, or a cell phone company's connection records for their entire network. Large databases often end up spread across several computers. These databases are then known as distributed databases because the data doesn't all lie in one place. Extremely large databases, like those maintained by social networks such as Facebook and Twitter, online services such as Amazon or Alibaba, and search engines such as Google and Bing, often have databases distributed across hundreds of servers and several continents. Digital databases have many benefits. Computers can easily store billions of records. These are stored on hard drives, solid-state drives, and magnetic tape, so they don't take up much physical space. Electronic records are easy to access, and with network databases, the data even doesn't have to be on the same continent, let alone the same building. As computers have become faster and more powerful, datasets have grown as well. This makes incredibly sophisticated processing possible, with the potential for discovering new information that otherwise would not be possible. This facility has been credited as the basis behind several major discoveries recently, from new electronic components to cures for medical conditions. This doesn't, however, mean that there aren't disadvantages. There's an increasing temptation to store unnecessary data, especially as we don't know what breakthrough in data analytics will suddenly make these data sets useful. This also carries with it the danger of information overload. This is that needle in a haystack problem, where valuable information gets lost in a flood of useless data. unused data also has costs. It needs servers and hard drives to store the data on. You need air-conditioned buildings to house the servers and technicians to maintain the centers. All this data has to be backed up, which means more servers, hard drives and buildings. And of course, it all uses electricity. And this is possibly the biggest cost of all. However, always remember that it is not enough just to store data. There's a famous principle in computing called the GIGO principle. Garbage in, garbage out. The results you generate from data can only be good if the data you're basing those results on is also good. Bad data leads to many of the errors in statistics which you may regularly encounter in the media. Good database management means trying to ensure that your data is valid and accurate. Validity is a relatively easy concept to check. This means the data you're capturing matches the sort of data you're trying to store. It is easy to make sure that a number has been entered when you're storing a number, or that a date actually exists. Accuracy is a different ballgame. When you give your birthday on a form, or your gender, I have no way of knowing whether what you entered is correct. We can limit errors by cross-checking, asking the same information in different ways, but it's still possible to have valid but inaccurate data. In some cases, data is structured to try and minimize errors, so vital numbers such as ID numbers, credit card numbers, and the ISBN used to identify books all have a checksum built in that you can use to check that the number is valid. Two-factor authentication and email confirmations also try to minimize the chance that people enter incorrect data, but even so, errors are possible. Limiting the range of what people can enter using validation rules, these are tests to make sure the data is valid, and input masks, which force input to conform to specific criteria, also reduce accidental errors. Still, it's impossible to ensure 100% accuracy, which is why crimes such as identity theft are possible. Databases are a very competitive space. A number of providers produce databases that have very different pros and cons in particular use environments. Companies such as Oracle, Pervasive, and Microsoft specialize in database systems for business. There are also a number of competitive open source alternatives, such as MySQL, which is also owned by Oracle, MariaDB, and PostgreSQL. MySQL, for example, is used to power more websites than any other database system. We'll be using Microsoft Access in this class. Access is Microsoft's personal database application. It's not designed for large numbers of people to work with or to manipulate large volumes of data, but it is very accessible and well suited to small business and home use. As W. Edwards Denning, the American engineer and statistician whose work with the Japanese leaders after the Second World War is credited as one of the inspirations behind Japan's rise to economic power, put it, without data, you're just another person with an opinion. Databases make it possible to have the data that prevents falling victim to opinions and fake news. In our next lesson, we'll take a look at how data is structured in databases to make it easy to manage, work with, and to access. Thanks for watching. I'll see you next time. Bye for now.